Quiz 33. A breakfast cereal provides 100 calories of energy per serving. Express the energy with units of joules. So the 100 calories are a food calorie. So that's a capital C. And each food calorie is equivalent to 1,000 of the smaller calories. And one of the smaller calories is equivalent to 4.184 joules. So now all we have to do is multiply this out. 4.184 times 1,000 is 4,184, and then we have to multiply that by 100. And so we'll carry over 2 zeros. 418,400 joules. Notice that the food calorie cancels out, the smaller calorie cancels out, and we're left with units of joules. 418,400 joules. Determine the speed of a 4-pound object with 5,000 joules of kinetic energy. The formula for kinetic energy is equal to 1/2 mv squared. The kinetic energy is 5,000 joules equals 1/2. Now we don't have the mass, we have a 4-pound object, and in an earlier lesson we learned that there were approximately 2.205 pounds per kilogram. So when we multiply, the pound unit will cancel out and we'll have units of kilogram, which is appropriate for mass. So 1/2 times the mass times the speed squared. So now we need to get out our calculator, and we're going to get 5,000 joules. We have to multiply 2 by both sides, divide by 4 on both sides, and then multiply by 2.205 on both sides. And what we'll get is 5512.5, 5512.5. And now our units are going to be joules, and we're going to divide by this unit, which is a kilogram. And that is equal to our speed squared. So now we take the square root, and the square root of 5512 is 74.2. And the units of speed are meters per second. So when we take the square root of both sides, the square root of v squared is v, and the square root of 5512.5 is 74.2. Now, the unit, joules per kilogram, that's also underneath the square root button. So you might be wondering, how do we get meters per second from the square root of joules per kilogram? So let's look at that. Joules per kilogram. A joule is a Newton meter, and that is divided by kilogram. So what is a Newton? A Newton is a kilogram meter per second squared. And then we have to multiply that by the meter divided by the kilogram. This is all equivalent to a joule per kilogram. Here we have the kilograms drop out, and we're going to get meters squared over second squared. Meters squared per second squared is equivalent to a joule per kilogram. When we take the square root of the joules per kilogram, we're going to have units of meters per second, just like we got. So 74.2 meters per second. A 60 kilogram girl is running at a track and field stadium. Determine her kinetic energy when her speed is 2 meters per second. So the kinetic energy is equal to 1/2 mv squared. Alright, so her kinetic energy, that's what we're trying to find out. We have 1/2, and her mass is 60 kilograms, and her speed is 2 meters per second, and we square that. 2 times 2 is 4, times 60 is 240, divided by 2. That's going to give us 120 joules. So her kinetic energy is going to be equivalent to 120 joules. A 60 kilogram girl is running at a track and field stadium. Determine her kinetic energy when her speed is 4 meters per second. When her speed is 4 meters per second, kinetic energy is 1/2 mv squared. Kinetic energy, her mass again is 60 kilograms. But now her speed is 4 meters per second, and we square that. All right, so 4 times 4 is 16, divided by 2 is 8. 8 times 60, that's 480 joules of energy. Kinetic energy is going to be 480 joules. Remember, we're using that MKS system, the meters, kilograms, seconds. So our energy is in joules, our mass is in kilogram, and speed is in meters per second. 480 joules. I hope you're following our strategy for success. You write down your equation, you plug in what you know, you solve. When you're solving problems, it's best to follow this strategy. A 60-kilogram girl is running at a track and field stadium. Determine her kinetic energy when her speed is 6 meters per second. Kinetic energy is equal to 1/2 mv squared. Her mass again is 60 kilograms. So 60 kilograms, but now her speed is 6 meters per second, and we square that. 6 times 6 is 36, and if you take 36, multiply that by 60, you'll get 2160, and divide by 2, that's 1080. Her kinetic energy is equal to 1080 joules. Let's look at something. In each of these three problems, the 60-kilogram girl is just increasing her speed. So notice that she goes from 2 meters per second to 4 meters per second. She's going twice as fast. If she's going twice as fast, kinetic energy goes as the speed squared. She should have 4 times the kinetic energy. So whatever kinetic energy she has here, she should have 4 times the kinetic energy here. In this problem, she had 120 joules. Now she should have 4 times as much, and 4 times 120 is 480 joules, just like we got. What happens when she triples her speed and goes to 6 meters per second? Kinetic energy goes as the speed squared, so 3 squared is 9. She should have 9 times the kinetic energy. So 9 times 120 is going to give us 1080. Sometimes understanding proportions is a much faster way to solve problems. A car has an initial speed of 25 miles an hour and a kinetic energy of Ke sub 0. Determine the kinetic energy of the car when it's traveling at 75 miles an hour. So when the car is traveling at 25 miles an hour, it has a certain kinetic energy. So now it's traveling 3 times as fast. 3 times as fast, the kinetic energy is proportional to the speed squared. So if the car is traveling 3 times as fast, it's going to be 9 times the kinetic energy, because that 3 is going to be squared. So whatever kinetic energy that we had originally, we're going to have 9 times that amount. What degrees Celsius temperature is twice as warm as 0 degrees Celsius? At 0 degrees Celsius, the particles have a certain amount of thermal energy. What we want to do is know when the thermal energy is twice as much. That would mean that it's twice as warm. So our Kelvin formula is this. The temperature in Kelvin is equal to the temperature in Celsius plus 273.15. The temperature in Kelvin is equal to 0 plus 273.15. The temperature in Kelvin then must equal 273.15 K. So at this temperature in Kelvin, the particles have a certain amount of kinetic energy, a certain amount of thermal energy. When will they be twice as warm? When they have twice this energy. So I'm going to have to take this 273.15 and multiply it by 2. And that's going to give me a Kelvin temperature that's equal to 546.3 Kelvin. So what that means is at 546.3 Kelvin, the particles are twice as warm as they are at 273.15 Kelvin. So now let's answer the question and convert it back to degrees Celsius. We write down our formula. The temperature in Kelvin is equal to the temperature in Celsius plus 273.15. Just like we did here, we write our formula, plug in what we know, solve. We wrote our formula, we plug in what we know, 546.3 is equal to the Celsius plus 273.15, and we're going to get a Celsius temperature equivalent of 273.15 degrees Celsius. This temperature is twice as warm as 0 degrees Celsius. If the mass of an object is constant and the kinetic energy increases by a factor of 4, by what factor did the speed change? Kinetic energy is proportional to the speed squared. So if we double the speed, we're going to have 4 times the energy. We triple the speed, we're going to have 9 times the energy. If you have 4 times the speed, you're going to have 16 times the energy. If we have 4 times the energy, that means we doubled the speed. If the speed of the object is constant, but the mass doubles, so let's look at that. Kinetic energy is equal to 1/2 mv squared. We want to leave the speed constant, but we're going to double the mass. How is the mass related to the kinetic energy? It's a proportion. It's a direct proportion. So if the mass increases, the kinetic energy increases. If the mass decreases, the kinetic energy will decrease. And it's a proportion, it's a direct proportion by the same amount. In other words, if you double the mass, you're going to double the kinetic energy. If you triple the mass, you triple the kinetic energy. In this case, we're going to double the mass, so we're going to double the kinetic energy. A car traveling at 50 meters per second with a kinetic energy of 1.5 to the 6 joules. Determine the mass. We write out the formula. Kinetic energy is equal to 1/2 mv squared. We know the energy is 1.5 times 10 to the 6 joules equals 1/2. We're trying to determine the mass, and the speed is 50 meters per second, and we have to square it. So let's solve. We want to solve for that mass. So we're going to put in 1.5 to the 6th into our calculator. We're going to multiply both sides by 2, and then we have to divide both sides by 50, not once, but twice, because the 50 is squared. And we're going to get 1,200. The units of mass are kilograms because we're using the MKS system. So 1,200 kilograms is our answer. We write down our equation, plug in what we know, solve. That's all there is to it. Kinetic energy equals 1/2 mv squared. Energy is in joules, mass is in kilograms, and speed is in meters per second. All right? So a joule is defined as a kilogram meters squared per second squared. Or a joule is defined to be a newton times a meter. And a newton is a kilogram meter per second squared times a meter. And so we're going to get a joule is equivalent to a kilogram meters squared per second squared. You must solve all of these equations with the appropriate unit. Units are a crucial part of problem solving. You must know the units. I encourage you to keep working hard. I hope you did well with this. Have a great day.